Right. Good morning, ladies and gentlemen. Okay, I hope we have finished uh, with, doing and learning the recording from Alkenes, which I posted on the WhatsApp group, okay, through YouTube. And you also need to do the SLS module for alkenes and alkenes. Okay, you must uh, do whatever that I have instructed for you to do in the recording. That is, you need to play around with the models, right? Draw the alkenes, right? Get absorbed into the concept so that you can actually understand this topic more. Okay, right. And please play the video in the SLS, okay? Because this topic is very easy if you are able to grasp the uh, the the properties of alkanes, and you know how to draw the alkanes and alkenes. Okay, the key feature for you to it's important that you need to embrace when learn in HPL. You must be disciplined, and you must have a spirit of inquiry, and you must have this so-called um, a great attitude to study and to gather knowledge, right? Okay, and alkenes, these two compounds are very, very important, okay, in our daily life. Okay, why? Because uh, they are found in our energy sources, the fuels. Okay, so in order to support this petrochemical industry or fuel industry, we need to equip the scientists with all this knowledge first. Okay, alkenes is something very basic that you've learned. So I want you to appreciate this. Okay, so in order for you to consolidate your knowledge on this, you are required to do the exercise here. Okay, so this is page 233. Okay, page 233. Okay, so let us do the questions here. Yeah. Question number one, the first two members of alkene homologous series are ethene and propene. So what are the name and formula for the third member? So the third member means yes, sorry. Third member of alkene, do you think it's propene? Actually, no, just because third means it has three carbon. And you need to remember alkene's first member start with the two carbon atom member, that is ethene, right? So ethene first, propene second, third should be butene, B-U-T-E-N-E. So the chemical formula will be, okay, CnH2n, C4Cn, H2n, 2,8, right? Now, next, give the general formula for alkenes. So, general formula for alkenes, CnH2n. All right. Okay. Question one is it's quite easy, right? Next, you are going to draw the dot and cross diagram and structural formula for ethene. Okay, what is ethene? C2H4. I have shown you how ethene looks like in the previous video. So if you remember the structural formula, it has carbon-carbon double bond, right? And then there are 4 bonds here. Okay, right. Yeah, anyway, please do this worksheet first before you play this video. All right, you must do first. You need to try first. Okay, try to uh, do active recall what you have learned in alkanes and alkenes. You have to apply here. Then your understanding will be better. Your knowledge that you grasp, you will be staying inside your memory better, right? Will be long lasting. So, right, let's move on. Go and cross diagram. Remember, the double bond here means double sharing. So let's draw the carbon first. Okay, I apologize if the drawing not that great. Okay, it's very difficult to draw in this. Okay, so the carbon-carbon double bond. Okay, remember the double electron sharing. Okay, cross dot. For now. Cross dot. Just put dot there. I know this thing can be quite. Okay, right. Yeah, anyway, okay. Then the next, the two hydrogen here. on the second carbon, okay, since it is single bond, dot and cross only. This one also dot and cross only. Okay, so this for this and this. How about these two? Okay, same thing. Okay, dot and cross. Okay, all of these are here. Okay, so if you want a more clearer picture, you can check your resource book. Okay, next, ethene is a gas and it undergoes combustion, to give two products. Write the balance equation to show combustion reaction. Okay, what is the word equation for combustion of ethene? So ethene, when combust or burn in oxygen, we give you carbon dioxide and water. Okay, so balance equation, ethene C2H4. Okay, combustion must always have oxygen. Okay, right? A fire will only light up or will only burn when there's oxygen. No oxygen, no fire. Okay, right. Okay, however, this equation is not balanced. Okay, if you see the carbon is not balanced. Okay, carbon not balanced. So automatically you can put 2 here. Okay. Okay, then the carbon balance, right? Now, if you see this combustion equation for alkanes and alkenes, you can memorize that. There are 3 steps here. First, you balance carbon first. Then you look at the hydrogen and you balance the hydrogen. And lastly, you balance the oxygen. Okay, let's try that. So carbon 2 and 2, right? Hydrogen, there's 4 hydrogen here. Now you are supposed to make this hydrogen into 4, okay, to balance up this. So you put a 2 here, right? You will multiply 2 times 2, 4. Okay, and then don't forget, you put number 2 here, you will multiply not only H2, you also multiply O also. Likewise for carbon dioxide, 2C, 2O2. Now that makes oxygen on the right hand side is 4 plus 2. 4 plus 2, 6. Okay, so how to make the left side 6? Just put 3. Okay, now this oxygen, sometimes you can use fraction. Okay, you can use fraction. Yeah, when we meet that situation, I will explain you more. Okay, next question. Using ethene as an example, describe 3 addition reactions that alkenes undergo. In the reactions, write down the products that's formed. Okay. What are the addition reaction? Number 1, hydrogenation. Okay. So around the ethene undergo to form what? To produce. Okay, to produce ethane. Right. Okay, you don't need to write down the conditions for this case, right? Next, the next mark. See, there are 3 marks here. So what is the other addition reaction? Bromination, yes. And there goes bromination to produce. Okay, do you remember what's the name of the product? Okay, check your textbook. Okay, it should be 1, 2 dibromethane. Okay, right. That is the second mark. Next, remember the other addition reaction? Ethene undergoes what? Who can remember that? Addition what? Polymerization, right? Okay, remember polymerization? There are many ethene monomers come together, we give you polyethene. Okay, right. The plastic that is used to make our shopping bags. Okay, the plastic bag that we always buy when we go shopping, right? Okay, we will need to pack your groceries inside this plastic or polyethylene bags. Okay, next. Okay, done. Okay, cracking. Okay, now I told you that I don't want to go through this one first for alkene, for cracking. Okay, but now I want you to learn from this question, right? Actually, this is not a difficult concept. Cracking, it just comes from word crack. Means you break down a big alkane into smaller parts. Okay, just like you crack a window, you break the big window to smaller window. You crack a cracker, you know the cracker, right? Like a biscuit, yeah, from big cracker to a small cracker. Right. So now for cracking, there are few processes. Steam cracking or catalytic cracking. Okay, they have some conditions. That one I will explain further. So now let's look at this reaction. We have hexane will crack into ethene and something X. So what is this X? So in order to solve this problem, it X up surely must have carbon and hydrogen. So in order for you to find out how many carbon and how many hydrogen is found in X, you have to minus off the numbers here. Okay, so let's look at the carbon, 6 and 2. So this one should be 4, right? See? And how about this hydrogen? Should be 10. So when they add up, okay, right? Just like if you see a crack window, okay, the small pieces when you join them together should give the same whole window. Okay, likewise for cracking an alkane, the big alkane you crack together, if you join them together, should have the whole thing here. So C4 is 10. This is what? What is this? C4 is 10. Alkane or alkene? Okay, see numbers. 4, 10 is not 4, 8. If 4, 8, then alkene. So you have saved. This one easier to draw. So it's butane. C4 H10. Okay, right. Okay, I'll try to draw this properly. This is draw. Okay, right. Okay, so this is butane. 2B. Okay, question 2B. Describe a test to distinguish ethene and compound X. So what is the difference between ethene and compound X? Ethene and butane. Here the pronunciation properly. Ethene, butane. So one has carbon-carbon double bond, one has no carbon-carbon double bond. So, right, since this one has carbon-carbon double bond, we can use this substance called aqueous bromine. So, what we need to do for the test part, we add aqueous bromine to both compounds. So, what do you see for observation? Ethene will decolorize. Remember, use the word decolorize, right? Very important, right? This one is called marks. While sorry, bromine, but compound X will not decolorize. So yeah, S not Z. Always got confused. Okay, bromine. Okay, right. This is a very simple test actually. So when the question come out that requires you to distinguish between an alkene and an alkene, always think of this substance called aqueous bromine. So please remember that. Okay, right. Yeah, let's skip this one first. Okay, for cracking. Because I haven't gone through yet. So once we go back to school, we'll talk about it. Okay, next, write down the chemical equation for combustion of hexane. Okay, right, let's do this. So hexane, hex means 6. Hexane, right? Alkane. So alkane CN H2N plus 2. So 6 times 2 plus 2 is 14. Plus oxygen. Okay, will give you carbon dioxide gas, water. Okay. Right. Again, when you see a combustion reaction, remember these three steps. Okay, first, carbon, then hydrogen, then oxygen. Okay. All right. So now, let's look at the carbon. Let's balance carbon first. 6 here, 1 here. So it's just 6. Carbon balance. Hydrogen 14. 2 here. So multiple of 14 should be 7 here. Okay, please remember your maths. Now let's look at oxygen here. What's the total number of oxygen on the right hand side? So we have here 12 plus 7. 12 plus 7 should be 19. Okay, 19 oxygen. 12 plus 7, yeah, right. Okay. So how to make this 19? Okay, I tell you what. Remember maths? Okay, 19, you cannot put 19 here. You put 19 here, the numbers of oxygen will increase by double. So what you can do, you put a fraction, right? Just to erase these two, so-called erase these two. So if you put 19 over 2, and when 19 over 2 times 2, if you remember maths, this thing will cancel out. Okay, that's why then the total you got 19 here. Okay, think about it. So you can put 19 over 2. Okay, right. So this is the answer. Right. Next, incomplete combustion. Okay. Remember what does incomplete combustion produce, and which makes it undesirable? Yes, they produce two substances which actually which is actually quite hazardous for humans. Number one, carbon monoxide. It produces carbon monoxide, which is an air pollutant. You can explain why it's an air pollutant, okay? Right? Which prevents red blood cells from absorbing oxygen. Okay. The other one, remember soot. Okay, it produces soot or carbon. Okay, which stains cooking utensils and suffocate victims when trapped in fire. Okay, right. So see, this is chemistry. You learn that incomplete combustion produce something which can actually harm your life. All right. Okay, so that's why chemistry is important to learn. Okay, not only just to score grades, but you need to know the important part of chemistry. Is it actually help save lives too. If you don't know what's the dangers of carbon monoxide, how it's produced, right? Then how are you going to so-called you will just be careless and then you just burn maybe a kerosene lamp inside the tent or what, and it can cause carbon monoxide poisoning. Okay, right. Anyway, now let's move on. Okay, alkenes. Okay, question 3. Alkenes are unsaturated hydrocarbon. Remember, when you see the word unsaturated, it means unsaturated. It means carbon-carbon double bond. Okay, right. Carbon-carbon double bond. Okay, so now deduce the name and structural formula of the product when butene. This is called butene. Why called butene, not butene? Because the carbon-carbon bond starts at second carbon. Okay, you can ask me more about this when school open. So what happens when you add hydrogen? Okay, let's see. Hydrogen is H2. Remember addition? You add the atoms into the carbon-carbon double bond. Okay, so let's see how it is added. So hydrogen, this hydrogen go to this carbon, the other hydrogen will go to this carbon. So what do you get? You get butane and alkane. Okay, initially this one got carbon-carbon double bond, right? Now the carbon-carbon double bond will be gone. carbon bond will be gone. And the rest of the hydrogen is just copy. Right? Okay. So the product is butane. Okay, next. Okay, what happened? We had bromine now. Okay, bromine. Likewise, bromine is a diatomic element. Okay, since this is from group 7, okay, and group 7 has 7 electrons, then in order to have a stable octet configuration, bromine and bromine need to pair up together, right? Bond together so that it can have a stable octet structure. So what happened to the bromine? Likewise, same thing too, but use a different color. So for bromine, oh, everything changed. Okay, now. Okay. This bromine will go to carbon here. The other bromine will go to the other carbon. Okay, I repeat again, go to the other carbon, not the same carbon. So as a result, okay. Okay, remember these two, the formulae between these two carbon, there's carbon-carbon bond. Now there's no carbon-carbon bond, all except bromine. So the bromine will be here. Okay, right. And the rest, you just copy the original hydrogen that's from there. Okay. Right. What's the name of this product? Okay, this one is a bit tricky. Okay, how should we name this? Recently, 1,2-dibromo ethane. Remember 1,2 the recent one. 1,2-dibromo. Okay, now I want you to see how we name this, right? Okay, since you all are since you all okay, I need to turn on back this. Okay, okay, apologies for the disruption here. Okay, the PDF file just one longer. Okay, so okay, if you remember, we draw this. Okay, and the two bromine is between these two carbons. Okay. Okay, let me go back in. So then I told you how do we name this. Okay, if you remember, right? Recently, for bromine, sorry, for ethene, right? The two alkenes, the two carbon alkene. Okay, remember this? We name it as 1, 2, because the bromine is attached to carbon 1 and carbon 2, and there are two bromine. Means 2 means di, bromo. Okay, right, means there are two bromine, right? Then the last name must follow the long chain here. We call ethane. Now, okay, find the pattern. Try to transfer that pattern, learn that pattern, and to apply that pattern to this one. So look at this. There's the bromine. Is it at 1, 2? Look at the carbon. It's carbon number 1, 2, 3, 4. In chemistry, there is a module or lesson just naming the chemicals, right? That one I will be learned in A-level time now. So we have here the bromine is at carbon 2, carbon 3. So it should be 2, 3. Okay, instead of 1, 2, become 2, 3. And is it dibromo? Yes, still dibromo. Dibromo. Why dibromo? Because there are two bromine. Okay, so the last name will be follow the whole molecule will be butane. Okay, 2, 3 dibromo butane. Okay, right. That's it. Okay, let's move to the next question. Okay, alkenes can be polymerized. Okay, now so this is the polymer. Okay, remember this is polymer. There is a bracket. Okay, there are two lines jutting out, and there's n here. And if you remember, there's one thing called repeated unit. Okay, right. This is the repeated unit for this particular polymer lah. Okay, this is the repeated unit. But they don't ask for repeated unit. What do they want? They want to name the name. They use the name and structural formula for the monomer. Okay, the monomer. Let's find out how to draw the monomer. Okay, so the monomer, remember, okay, this is repeating unit. Different. Please learn how to differentiate the different names. Repeating unit. This is polymer. Okay, so monomer how? Okay, for the monomer, just remove these two lines and draw a double bond in the middle. Okay, remove the two lines. So okay, remember all monomers have double bond. So please remember that H, this CH3, H and H. Okay, so this is the polymer for it. So I want to see the pattern. So this is the monomer. Okay, monomer. All right, so of course we don't write the answer here. We need to write the answer below here. Okay, let me. Okay, so there's a carbon over here. So remember there's H here. There's a CH3 here, and the H and H. Now what's the name of this? It looks so unfamiliar. Correct or not? Sorry, this is CH3. However, you have learned this already. Okay, let's orientate back. Okay, this will orientate to this. So you have H. Let's look at this part first, right? Carbon double bond. You need to make some effort to redraw back. This one is H. Does this look familiar? Carbon with only one H in the middle. Then this one CH3. What is this CH3? What is this? Does this mean this one too? Is this CH3? Yes. Okay. So this and this is the same. So what is this? When you substitute this to this. Okay. Right. So this is called an alkene with 3 carbons. So what is it? And it's called yes, this. Okay. It's called propene. Okay. Right. Next. Okay. Draw the structure of the polymer form from the following monomer. Okay. Again, right. What you need to do, you need to orientate this to something like this. Okay. Double bond is like 4 lines on top of each other like that. Okay. Okay. So how are you going to orientate that? Okay. First things first. Okay. Draw the carbon double bond first. Okay. You need to redraw. Okay. These two carbon bond. This carbon got H. So H stays here. Then this carbon also got this thing called CH3. So just condense it, become this whole branch structure. You just condense it by writing down CH3. So this the CH3. Yeah. So this part down already. Okay, this part down already. How about the left part? This one also quite simple. Just straighten out this. Okay, make it 90 degrees. Chlorine. Then H. Now, can you make it to a polymer? Okay, let's look at the above example polymer. Polymer should look like this. No carbon bond. You must have the bracket. You must have the N. And you must have these 2 lines jutting out. Okay, let's try. Okay, again, bracket and 2 lines jutting out. CC. C, no double bond. Please remember, most students are always trying to draw double bond here. Okay, either they are careless or they just ignorant. Then this part carbon, get chlorine and hydrogen. The other part of carbon, sorry, H3 and H. Okay, right. So this is a polymer. Let's draw the repeating unit. Repeating unit, I think I've drawn already for you here. Okay, so the repeating unit is similar like polymer, only there's no bracket and end. Okay, right. Please learn how to differentiate this, appreciate the difference. Okay, because if your brain is sensitive to the difference, it will actually help you a lot in your work, where you can pick out mistakes or something, patterns or etc. Okay, right. Let's move on. Okay, only more to go. Oh, not so much. Oh, still not. Okay, right. Let's see how long we can go here. Yeah, pause the video if you feel tired. Anyway, next, describe the for pollution problems caused by disposal of polymer. So, what is the pollution problem? Okay, landfill sites. First of all, it will cause land pollution. Okay, because the polymers are non-biodegradable. Means it will take up land space. All right, take up land space. All right, or you see rubbish anywhere. So, and burning, when you burn plastics, usually toxic fumes will be produced. Right. Okay. Next. Okay. I haven't covered about this polyunsaturated part. Okay, but let's learn from the question itself. Okay, the question itself lends itself to will provide some learning opportunities for you all. Okay, even though you haven't learned this term yet. So let's look at the term polyunsaturated. Looks like something has to be poly. What's poly actually? Okay, what's poly? Okay, so poly means actually a lot. Okay, more than one actually. Okay, when I say polynomial, okay, which there are more patterns, right? Polyclinic, okay, inside the clinic there is more than one clinic. Polytechnic, there is more than one technical course inside there, right? So polyunsaturated means, okay, it means a compound, okay, that have more than one carbon bond. Okay, it's called polyunsaturated. Okay, next, let's move on. So cooking oils, those people who actually learn about who took FNN, right, food and nutrition, you know that cooking oil has polyunsaturated and fats and saturated fats. So cooking oil can be converted to margarine. So a chef prepared 4 samples of cooking oils, Q, R, and S, of 10 grams each. He tried to convert each sample of cooking oil to margarine by bubbling 100 centimeter cube of hydrogen gas. So cooking oil, initially all cooking oils have carbon bond. But once if you add hydrogen, the cooking oil will turn to margarine, and that margarine will not have carbon bond. It will not have carbon bond. Okay, right. Sorry. So cooking oil can be converted to margarine. So we have sample QRNS. So what happened here? We have hydrogen gas, which is passed through 3 samples of cooking oil, Q, R, and S. Now, once they pass through all these 3 oils, cooking oil, they found out there's some changes here. Okay, especially for Q and R, but there's no change. Sorry, Q and S, but there's no change for R. So what happened here? R. Okay, what happened here? So this is something that you need to take note of it. So next one, state the conditions need for the conversion of cooking oil to margarine. Okay, if you remember, This is hydrogenation. For hydrogenation, there's two conditions. There are not temperature. So yeah, it should be presence of nickel catalyst. Okay, and 200 degree Celsius. So great. So yeah. This one you have to write down properly. Yeah, since I'm typing very difficult for you to switch here and there. Okay. Now, next question. Which sample of cooking oil did not contain polyunsaturated fats? Okay, now look at this. Okay, you can see that R, there's no change. And why does R don't change in terms of the volume of hydrogen gas? Is because R don't have the carbon-carbon double bond to absorb the hydrogen. Okay, if you remember, in addition reaction, right? Okay, let's say if something got carbon-carbon double bond, then there's hydrogen, right? So the hydrogen will get absorbed into the carbon-carbon double bond, and as a result, the carbon-carbon double bond will disappear, right? Right, and then you get the hydrogen here. Okay? So that's what happening for Q. And that's what happens for SO. So that shows that R is not is a saturated compound. Okay, right. So which then that makes us to answer this question: which substance of cooking oil did not contain polyunsaturated fat? Okay, sample R. Why? Because the volume of hydrogen gas not change. Okay, not change, which indicates that the sample are not have carbon bond, right? No carbon bond, so cannot absorb the hydrogen. Okay, right. Let's move on. So this is a question, right? This is a very good question. So practice 2 or 3 times for you to understand the meaning of addition. So addition reaction or hydrogenation reaction. This is how you apply whatever you have learned for alkenes hydrogenation reaction to something more difficult question. Okay, next question. Suggest another test to distinguish between the cooking oils. One contains polyunsaturated fats. The other one do not have polyunsaturated fats. So what do we do? What do we add? Unsaturated carbon-carbon double bond. What is the chemical? Turn it to add equals what? Who can remember? Start from the B. Bromine. Okay. So with unsaturated fats, since unsaturated fats got carbon-carbon double bond, so bromine will be okay. How about the one without unsaturated fat? Bromine will not be okay. Next question. Describe describe the manufacturing of smaller alkenes from long. Okay, this is cracking. Okay, but let me skip this question first. For C. Okay, now let's move off to 5. Question 5. This one looks like QA, right? It's not QA, just a normal chart kind of question. Now you have P. Okay, P at equals bromine. You have this. So what does it say about P? Since there's the equals bromine here. Whenever you see equals bromine, right, always linked to this thing. Maybe there's a presence of carbon-carbon double bond. Okay. So what is P then? And this P has 2 carbons. When you look here, has carbon-carbon double bond. So 2 carbon alkene is called E. Okay. Next, can okay, identify what is Q, R, and S. So what is Q then? So if this is an ethene, right? So when you do hydrogenation, you get an alkane. What alkane comes from ethene? It obviously should be ethane, right? We call it an alkane. Now, alkene you burn give you R and S in an excess oxygen. What reaction is this? Combustion. Okay, so R and S, there's no preference. You can either write down which is water vapor, which is carbon dioxide. So this is carbon dioxide and water vapor. Or you can write water vapor for R, carbon dioxide for S. Both can. What's the necessary conditions for P to form Q? The necessary condition that is okay, hydrogen gas, okay, uh, nickel catalyst, 200. Okay, right. Now let's write down the balance equation for formation of R and S. Okay, R and S. This one, R and S. P to R and S. So what is P? P is in C2H4. Okay, number is combustion. And this will be carbon dioxide and water. So there are two carbon here. Again, balance carbon first. Hydrogen is 4 here, equal 2 here. Okay. Lastly, 2 plus 3, 2, 4 plus, okay, lastly the oxygen. You have 4 plus 2 oxygen to be 6. 6 oxygen on the right side, and you must make the left side 6. How you can do that? Write down 3 here. Okay. All right. Right, next. Propene and propane are both organic compounds. Okay. State one similarity and one difference between the structure of propene and propane. Draw the structure of propane and propane. Oh, okay, so I need to draw. Let's draw propane first. Okay, let's label it, right? Propane, 3 carbon. This is propane. And then the other one here is a propene. Okay. Remember, draw the carbon double bond first. Okay. Right. So this one should be propane. One should be propene. Okay. Right. What's the similarity between these two? Okay. So both are hydrocarbons. The difference is propane is saturated hydrocarbon, while propene is an unsaturated hydrocarbon. Okay? Okay, next, let's move on. How do they react, if at all, with chlorine and hydrogen? Chlorine. Why? Somehow this one looks familiar, right? Chlorine. And what is hydrogen? Okay, now let's look. Okay, chlorine. What reaction involves chlorine? Okay, remember this thing called substitution. Okay. But how about alkene? Alkene can react chlorine on. Actually can, but that is the A-level stuff. But let us do the O-level. Okay. Now hydrogen is the addition reaction. Okay. Now propane with chlorine. Write down the chemical formula, chemical equation, also implement. Okay. So propane with chlorine. Okay, the chemical equation here. Let's write down here. Propane C3H8 plus chlorine. Okay, if you one of the chlorine gets substituted to become C3H. Now one of the hydrogen gets substituted from it becomes 7Cl. Then this chlorine also one of the chlorine gets substituted become got hydrogen chloride. Okay, right. So the name of the product forms are, you have to write down there, products. You have to be hardworking in order for you to score the full marks. So we have this one should be chloropropane. HCl is hydrogen chloride. Okay, right. Next, B, propene with chlorine. Okay, actually this one propene with chlorine. Let's skip this one. Okay, actually there is but okay. Yeah, okay. I think it's still in syllabus. Okay, no, I think my mistake now. So does propene react with chlorine? I think can, right? If alkane is you undergo substitution reaction, or if alkene go addition reaction. So for addition reaction, for propene, it will behave similarly like bromination. Okay, right? Since chlorine is in the same group 7, bromine is also in group 7. So propene C3H6 plus chlorine. So this one is added. You add the thing inside the molecule. So C3H6 Cl2. Okay. So is there any so this one must have condition, right? Okay. So this one has must have a UV light. UV light. Okay. Next. This one there's no condition. Okay, how about with propane with hydrogen? This one no reaction, right? No reaction. No reaction. Okay, there's no hydrogenation for alkenes. For alkenes, yes, there is hydrogenation. Okay, what's the product for this one? Okay, the product is right now. Okay, call it 1,2-dichloro. Propane. Okay, right. How to get that? Okay, let me show you. Okay, propene. Okay, this is propene. All right. So when you add chlorine, one will go here, one will go here. Right. So after that, you have carbon 1 and carbon 2 occupied by chlorine. Okay, this is the rough drawing. Okay, rough drawing. Okay, how about propane and hydrogen? You will have a reaction called hydrogenation. So propene C3H6, okay, nickel catalyst. Hydrogen, okay, got a nickel catalyst, and 200 degrees Celsius. All the conditions that you can write down here. You got C3H. Remember, addition reaction, you add the products together, right? C3H. Okay. So what is the name of the product? Okay. Okay. Right. Last question. Right. What is the volume of oxygen measured at room temperature and pressure needed to burn 10 dmb of propane? This is a more concept question. Okay, so propane. Let's the question first. Okay, always write down the equation. Propane C3H6 plus O2 will give you carbon dioxide and water. Okay, again, balance the carbon, then hydrogen, then lastly oxygen. carbon 3, 6 hydrogen here, so you make hydrogen 6 by adding 3 here. Lastly, count the oxygen here. Total here is 6 plus 3. 6 plus 3 is 9 oxygen. So you want to make it 9, right? Okay, remember, you can use fraction, right? Okay, you have to get rid of 2. Okay, math, remember, 9 over 2. Okay? So now you have a situation. You want to find the volume of oxygen when you are given 10 dm cube of propane. Okay, I shall give you a shortcut for this. Remember, I told you when you want to solve this problem, must find out the mole, then ratio, then convert, right? Okay, for gas, there's a shortcut, right? Gases only, gases only. So for gases, right? Okay, I haven't went through this sometimes because I got no time. Okay, so by if we call it Avogadro's gas law, okay, right? I don't get confused for this one because it's only applied for gas. So for gas law, you can compare directly. So then you can say C3H6. So yeah, there's no stuff here to O2. Right? What's the ratio from the equation? 1 is 2, 9 over 2 or fraction. So if you have 10 dm cube, how? So this one use ratio. 10, remember, 10 times 9.2 is 1. Okay. 10, 10, 10 times 9 over 2, right? And the answer, you divide by 1. Okay, so how much is this? Okay, so it's a 90 divided by 2. 90 divided by 2, let me check. 45. So it's actually 45. Oops. 45. For those people who still don't understand what's ratio, please revise your maths. Okay, right? Yeah, I'm quite angry because some of you cannot even do ratio. But in primary school, a lot of time we do ratio. And teacher, how is this? How is this? Okay. And some of your express students, you are expected to know all this. Okay. Right. Next. So, what is the answer? Answer is, yeah, that's it. Yeah. Therefore, volume of O2 is produced is equal to 45 dm cube. All right. So that's it. Okay. So that's it for today's video. So please do the exercises first. Try your best. If you're not sure, then refer to this video. Okay. You need to learn how to learn independently and be more disciplined. Right. Okay. O level is near. If you still want to be in your so-called playful mood, etc. Okay. Please don't blame us if you are crying during the O level release result. Okay, right? Most of you don't want to go poly, right? Then please study hard. Okay, so all the best for you to check the answer for this. Okay. Okay. So thank you. Goodbye.